It's 7:31, so I guess we'll start. Share my screen here. So, welcome to What's Up Over Edmonton for the month of April 2023. My name's Jeff Robertson, and I'm a member of the Royal Astronomical Society of Canada, Edmonton Centre. And here we are in April. The snow is melting, and the Masters starts tomorrow, so we know it must be spring. Call this What's Up Over Edmonton because the skies where we live at 53 degrees north latitude are quite a bit different than what's presented in most popular astronomy publications and stuff you see online. And this is my example I use every month. This is the sky over Toronto on July the 5th at 11. And I note the constellation Scorpio right here is fully visible from head to tail. Where in Edmonton on July the 5th, we only see the top part up until midway through the body. We never see the tail. We never see the stinger. We never see the whole constellation. And likewise, the same for Sagittarius right next door. We never see that whole constellation from where we live either. And also how we see the sky is a bit different. This is a picture I took on February 23rd from my backyard, where the moon at the top and Jupiter in the middle and Venus were all lined up. It got a bit of ink in the papers. And my sister's cousin, who was in Bucerias in Mexico at the same time at 20 degrees north latitude, this is what she saw that same night. And you'll note in Edmonton, the moon and planets are at an angle, and in Mexico, they're almost in a straight line down to the horizon. Well, not only do we see different things, we see things different. Most of the information I use comes out of the Observer's Handbook, which is put out by the RASC every year. It is 352 pages of just about anything an amateur observer could ever hope to want. I also use information from Astronomy Magazine and, unfortunately, the now defunct Sky News. The last issue came out a few weeks ago. So what do we have? In April, we have longer spring days and taxing times, and we all know what that means. It comes up at the end of the month. So we've got the nights that are getting shorter and at an increasingly faster rate. It's really picked up, I've noticed. We've got Venus very prominent in the west after sunset. We have the Lyrid meteor shower, which peaks on the 23rd of this month. First meteor shower of the season. And we have International Astronomy Day on April 29th, and I'll be talking about that a little bit later. Let's start by going over the sunrise and sunset times for the month of April. So today on April the 5th, the sun rose at 6:57 a.m. It sets at 8:16 p.m. and astronomical twilight ends, that is, night begins at 10:25 p.m. We have 13 hours, 19 minutes where the sun is above the horizon on the 5th. And where the sky is truly dark lasts for only 6 hours and 21 minutes. On the 30th, the sun rises at 6:01 a.m. It sets at 9:02 p.m. for 15 hours where the sun's above the horizon. And astronomical twilight ends at 11:46, and we have 3 hours and 25 minutes where the sky is truly dark at the end of the month. Let's look at the evening planets now. I've set the time for 8:31, which is 15 minutes after the sun sets today, and you can see Jupiter right on the horizon. And really, for all intents and purposes, you aren't going to be able to see Jupiter. It's just lost in twilight. It is in conjunction with the sun. That is, it swings behind the sun from our point of view on the 11th. So we're not going to see Jupiter this month. Later on in May, you'll see it emerging into the morning sky. Mercury's in the evening sky right now. Tonight, it sets at 10:08. So here it is here. It was actually brighter at near the end of March because Mercury is a rocky planet, and as it rises higher, its phase shrinks. Today it's a slightly gibbous phase. When it reaches greatest eastern elongation, it will be half phase. That happens on the 11th. As a result, the planet will get dimmer because there's less light falling on the part of the planet we can see. And if I make the sky a little bit darker, set it for 9:30, you can watch Mercury as it does climb a little higher in the sky each night. And then as it passes between Earth and the Sun, it gets lower and lower, and by the end of the month it is lost. On the 20th, Mercury and Uranus are only a few degrees apart, and they are also joined by a very, very thin, less than 1 day old crescent moon below them. The appearance of the crescent moon marks the end of the holy month of Ramadan for those who follow the Islamic faith. Moving on to Uranus, its time in the evening sky is just about done. On the 5th of April, it sets at 11:15. By the end of the month, it's setting at 9:45 and will be lost in the evening twilight. And if we follow it day by day, there you see it passing Mercury. And there's the moon joining us on the 20th. And the sky is brightening. And by the 30th, it's just above the horizon, but it's like I say, it's lost in the evening twilight. Moving on to Venus. Venus is the star of the evening sky. It is up well into the evening. On the 5th, it's setting at 12:06. By the 30th, it's actually setting at 1:02 in the morning. Tonight, Venus displays a slightly gibbous phase as it moves in its orbit toward greatest eastern elongation, where it will exhibit a half phase. And it's the cloud-covered planet, which reflects a lot of sunlight, will just seem to get brighter and brighter. I've mentioned this in the past, but I think it bears repeating, that Venus follows 5 different paths through the evening sky and also in the morning sky over an 8-year period, and this cycle repeats itself. These are the cycles shown here, starting with the one we had the last time it was in the evening sky about a year ago, where Venus rode fairly low in the sky throughout its time. And now we're in this cycle here, where it rises very high up. Once it reaches its highest point, it will start to descend fairly rapidly. Throughout the month, Venus meets up with a few interesting celestial objects. On the 9th and 10th, it is near the Pleiades, and that will make a really good picture. And then a few days later, on the 13th and 14th, it is placed between the Hyades, which is this V-shaped cluster of stars here, and the Pleiades. The Hyades is actually an open star cluster, but it is a lot closer to Earth than the Pleiades is. So we see it more as a bunch of stars spaced out, but there's actually quite a few stars in the Hyades star cluster. And the moon joins Venus on the 22nd and 23rd. When the moon and Venus are close together in the sky, it causes a lot of people to look up and notice the planet and wonder, what is that bright object there sitting next to the moon? When they're really close, and unfortunately we're not going to have that this month, you can get a really nice picture like this one I took a few years ago. Moving on to Mars, it's still with us, although it is faded a lot since its glory days when it was at opposition. Mars is now a first magnitude object, and it is moving through the constellation Gemini. Here it is on the 5th, and here it is on the 30th, and as you can see, it is shrunk a little bit more. So throughout the month of April, day to day, Mars moves through Gemini. On the 25th of the month, it's joined by a half moon. And again, that would make a really nice picture. And continuing on to the end of the month. Here it is on the 30th, well within Gemini, but it is going to move out and eventually move into Cancer, and it will make a close pass to the Beehive cluster. But we'll talk about that in a future episode. On April the 5th, Mars will set at 3:47. By the end of the month, it's setting at 2:54. Mars is going to be hanging around with us for a few months yet. As far as the morning sky goes, the only planet visible right now, and it'd be a very tough target tomorrow morning, would be Saturn. This is the view at 6:15, so Saturn is just coming up over the horizon. It was in conjunction with the Sun in February, but because the ecliptic is so low in the morning this time of year, it really doesn't come into view. If we go to the end of the month, and this is at 5:15, Saturn is a little bit higher up in the sky and a little easier to spot. But you're going to have to get up really early in the morning to see it before it is lost in the twilight. Uranus, Neptune, and Jupiter, they're just not visible from our latitude here. And before we leave the planets, let's point out the dwarf planet Ceres, which is well placed high in the sky in the evening, near the bright star Denobula, the hind end of Leo the Lion. We have a meteor shower this month, the Lyrids. It's the first meteor shower of the spring season. It peaks on the night of the 22nd into the 23rd, which is a Saturday and Sunday, so you can stay up late. The radiant for the Lyrids is up in the northeast sky as darkness falls, but it will rise higher and higher throughout the night. There's the radiant there. The constellation Lyra contains the very bright star Vega, and you might be familiar with Vega as part of the summer triangle. And so there it is there, which may help you find the radiant a little bit better. The radiant is just off to one side from the star Capra Lyra. So, dress warm. Take some hot coffee or hot chocolate or something and a blanket and a chair. It's not a great shower. You get about 10 to 15 an hour, but sometimes there are surges. It's been reported in the past that sometimes you see 100 an hour. But the standard rate for the Lyrids is 10 to 15, and again, no moon. So we don't have to worry about that big source of light pollution wiping out the fainter meteors. So get out of town, get away from the city lights, make sure the lights are behind you. So don't go south, go north or northeast to see the Lyrid meteor shower. If we look north, we can see the constellation Cassiopeia low in the northwest sky, sometimes called the W, or at other times of the year when it's flipped over, it's called the crooked M, or the crooked W. And if we look straight up, there is the Ursa Major, the Great Bear. Most people are more familiar with the asterism of the Big Dipper, and its bowl is facing downward, and as I mentioned last month, it was believed in ancient times that the spring rains, the April showers, if you would, come pouring out of the dipper onto the earth to water the ground below and allow our crops to grow. Looking to the northeast, and this is at 11 o'clock in the middle of the month, we see the aforementioned Lyra and Cygnus, the swan, rising up. And throughout the spring and summer, they will be higher and higher every night until they are almost directly overhead by late summer. The summer triangle is one of those asterisms that stick around for a long, long time throughout the late spring, throughout the summer, and certainly into the fall. Contrast that with Virgo, the home of the great Virgo galaxy cluster. And there's Virgo there. In the arms of Virgo, there are dozens upon dozens of galaxies. April is galaxy season. It's a time, if you get out of the city to a dark site, you can see literally dozens of galaxies in this area. And you can see them all, some of them listed here. But the time doesn't last very long because our days are getting longer and the nights are getting shorter. And by the middle of next month, we're going to be into perpetual twilight. And some of the fainter galaxies, you just won't be able to see them. Other constellations, such as Orion, by mid-month, it's pretty much gone. You are seeing Leo riding very high up in the sky. Cancer's high in the sky. It's a faint constellation, but there is the Beehive cluster. There it is right there. It's a lovely item to see in binoculars. And the moon does pass by the Beehive on the 26th and 27th. There it is there. And Virgo, which I just mentioned, with its plethora of galaxies held in its arms, or sometimes known as the bowl of Virgo, all in this area here. There's also some galaxies here in Leo. And Libra, the scales, is starting to rise, but Libra, and then right behind it, Scorpio, you can just see the top of it. This is at 11:30 mid-month, starting to come up over the horizon. It is really only really visible in the summer months when it is above the horizon, when it's a very bright star, Antares, the heart of the Scorpion, which we can see in Edmonton, even if we can't see the whole constellation. We can't see its tail and stinger, etc. There's the constellation Hercules, which in my mind is more of a late summer, early fall object, just because it's so very well placed to see from the RASC Observatory in Coronation Park. Hercules contains one of the nicest objects in the sky, I think, which is the Great Globular Cluster M13. There it is there. And it's located between these two stars in the Keystone asterism. There's the asterism there. I like showing people globular clusters through a telescope because they and the moon are objects that actually look like they appear in photographs. Nebula and such, they're always colorful and that, but when you look at them through a telescope, they look just gray. Or maybe a tint of green if they're fairly bright. Globular clusters and the moon actually look like they do in the photographs. Before I close, let me just mention that April 29th is International Astronomy Day. It's a Saturday. We haven't had one of these since 2019 because of COVID. So we're hoping that the weather cooperates, and we will have a table set up inside the TELUS World of Science, so you can come and talk to us. Hopefully we'll have a display. We had an incident a few weeks ago, which I'm sure our president will go into during our next regular meeting on the 17th, which you can join either in person or on Zoom, explaining the situation. It's still a bit of a fluid situation, but hopefully we'll get something resolved by then. But anyway, we will have a table, and some of our people will be there and we're going to be opening the observatory for extended hours. We're going to open it in the daytime between 1 and 4 for solar viewing, and then in the evening from 7 until midnight. So in terms of solar system objects, we'll have Venus, Mars, and the Moon in Ceres to train our telescopes on, as well as some other items as it gets a little bit darker. Maybe some double stars, maybe the beehive. We'll see. It's really up to the volunteers at the deck to determine what they're going to point the telescopes at. So if you're in the area, if you're in Edmonton, if you got nothing better to do on a Saturday, come on down, say hi. So let's just watch the sky as the summer constellations rise through the night of the 29th and 30th. There's Scorpio coming up. Before you know it, the sky brightens and the sun comes up. And I will say thank you and ask if there's any questions. So, that was obviously pre-recorded. And are there any questions? Comments? Tomatoes? No? Okay.
The Lyrid meteor shower.
Yes.
Is it? Are there quite a few meteors the day before and after?
There's a few. It actually goes because the Earth is passing through the debris left behind by a comet. There are a few, before and after, but the peak when we go through the thickest part of that debris field is the 22nd, 23rd. So yeah, there are a few. You may see one or two or three an hour beforehand and afterward.
Okay, thanks.
Okay, yep. All right, we'll go on to the moon.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon? It follows a path.
Okay, the moon is full tonight on the 5th. The April full moon is also known as the pink moon and has several other names. The breaking ice moon, the moon of the red grass, the egg moon, the budding moon. It has actually quite a few names. The new shoots moon, the seed moon, the growing moon, the awakening moon is the world or the earth wakes up after its winter slumber, and the birds lay eggs moon, and also the paschal moon because it's in relation to Easter. And Easter is on Sunday because the April 5th full moon was the first full moon after the equinox, and the Sunday following the first full moon after the equinox is always Easter Sunday. Yeah, there's the name. Third quarter is on April the 13th. The moon is new on the 19th. And first quarter is on the 27th. And the lunar feature I am going to talk about today comes from the Explore the Moon with a Telescope certificate program. Now, many craters on the moon are named after famous scientists, philosophers, explorers, mathematicians, among others. And there's a few that are named after historical figures. So the feature I chose tonight was taken from the Observe the Moon with a Telescope certificate program, and it is named after a historical feature, one who has his name on one of the greatest works of English literature. So the following is an excerpt from this work, performed in 1960 by the greatest actor this country has ever produced, living or dead.
Finds himself a holding to us all. You gentle Romans.
Friends, Romans, countrymen, lend me your ears. I come to bury Caesar, not to praise him. The evil that men do lives after them. The good is often interred with their bones. So let it be with Caesar. The noble Brutus hath told you Caesar was ambitious. If it were so, it was a grievous fault. And grievously hath Caesar answered it. Here under leave of Brutus and the rest. For Brutus is an honorable man. So are they all honorable men. Come I to speak in Caesar's funeral. He was my friend, faithful and just to me. But Brutus says he was ambitious, and Brutus is an honorable man.
So the crater is Julius Caesar. And there is a wide view of it with an arrow pointing at it. And it's located directly west of the Sea of Tranquility. It's an ancient lava-filled lunar impact crater with a heavily worn wall. It's 85 kilometers in diameter and 3.4 kilometers deep. There it is there. It was named after the Roman statesman Julius Caesar, and it's best seen around first quarter. This is a picture I took just as the sun was lighting up the far rim of the crater. You can't actually see the floor. There it is there. And this is a picture I took of it a few days after first quarter, where the crater was fully eliminated. And like I said, it's near the Sea of Tranquility, and actually it's, well, it's, I wouldn't want to walk this distance, but X marks the spot where Apollo 11 made the first landing on the moon. The crater is very old. And as you can see in the picture, it was formed by an impact very early in the moon's history, possibly in the first 500 million years of the moon's existence. And its shape was distorted by the impact that created the Sea of Tranquility, which came later during the late heavy bombardment period of the moon. And this is a picture from the Lunar Reconnaissance Orbiter, the best picture I have. And you can see the floor is fairly labeled, or the crater floor is fairly level, I should say. The northern half of the floor is darker than the south, and that's thought to be ejecta from the impact that formed the Imbrium Basin. And there are a number of crater remnants overlapping the rim, as you can see. The east wall is almost completely destroyed. And there is a low ridge, you can see it right there, that crosses the floor in the northeast section of the crater. So that's the crater Julius Caesar. Now, for the constellation, I've chosen, and I found two pronunciations of it. So Canis Venetici, or Venitici. Some people say Venitici, some say Venitici. It's a circumpolar constellation. There it is right there. Located between Ursa Major up here and Butes down there. And it's supposed to represent the hunting dogs of Butes the herdsman. And there's an ancient drawing of Butes holding his dogs in check. Now, Ptolemy, who's created the first constellation maps that were used for centuries, included these stars in the constellation Ursa Major, but the constellation was actually not formally introduced until 1687, when a Polish astronomer, Johannes Hevelius, created it from the faint stars located under Ursa Major's tail. Now there are two naked eye stars in the constellation, which does make me wonder how anyone saw an image of two dogs. Now this is the border of the constellation. It's got quite a wide border, but there it is. It's just kind of like a stick for the dog rather than anything else. The brightest star, there's only actually two stars you can see with a naked eye in this thing. The rest are all below naked eye magnification. Brightest star is Cor Caroli, and it's a magnitude 2.9 double star, and it's 110 light years from Earth. And the only other naked eye star is this one, Chara, which is a yellow-hued main sequence star with a magnitude of 4.25. It's about 27 light years from Earth, and it's actually very similar to our own sun. Now, there is one other star of significance within the constellation. You need a telescope to see it, and it is the Supera, and it is a carbon star with a beautiful red color, and it's about 100 light years away. It's a red giant at the end of its life with a lot of carbon ash in the outermost atmosphere, which gives it its red color. Now, Canis Venatici may not be interesting in terms of stars, but within its borders are 5 Messier objects. All of these Messier objects are galaxies, spiral galaxies, except for one, M3, which is a globular cluster. And you can see them all marked here on this image here. So the first one, M3, it's one of the brightest globular clusters in the sky, and it's an apparent magnitude of 6.2, which means you can see it with binoculars and certainly see it in a telescope. And it's approximately 33,000 light years from Earth. Contains an estimated about 500,000 stars, all clumped together. There's a number of these globular clusters. I believe the number is 150 that hang out on the outskirts of our Milky Way galaxy. Next object is M51, better known as the Whirlpool Galaxy. This is an image taken by one of our members. And it is a favorite target of astro imagers, and it's usually associated with Ursa Major because you use the stars in the tail of the bear or the handle of the Big Dipper to find it. It's located only 3.5 degrees southwest of Alkaid, which is the star at the end of the Dipper's handle. Has an apparent magnitude of 8.4 and lies about 23 million light years from Earth. Next one is M63, also known as the Sunflower Galaxy, and it's 37 million light years from Earth, and its magnitude 9.3, a telescopic object to be sure. Fourth one is M94, also known as the Cat's Eye Galaxy, and it's got a magnitude of 8.99. It's 16 million light years from Earth. And the last one is M106, which is a spiral galaxy that lies around 23.7 light years from Earth and has a magnitude of 9.1. So that is the hunting dogs. So we'll go on to space history. So this is where we look at a past event that not only occurred in this month, but whose anniversary year is divisible by 5. So in 2023, we look at events that happen in years ending in 3 or 8. Now, of all the objects I like to show people at the RESC Observatory in Coronation Park, Saturn is my favorite because it gets the best reactions. You get, oh, wows, and this can't be real, or is there a photo at the end of the scope? With its bright rings, Saturn is a jewel through a telescope, and even my first telescope, which was a small Tasco refractor I got for Christmas in grade 5, you can see the rings on Saturn. This is an image I took through my 8-inch scope. It doesn't really do it justice compared to what the eye can see or what other people have made for images, but I admit I am the world's worst astro imager. So when we think of probes sent to Saturn, we think of the Voyagers that flew by in the early 80s, or Cassini, which orbited the planet for many years. And we relate to images like this one here, which is just a fine image taken by Cassini. But the first visitor to Saturn took this image, and it left Earth 50 years ago tomorrow, actually, on April the 6th, 1973. And that visitor was Pioneer 11. Now, last March 2022, I talked about its sister ship, Pioneer 10, but I'm going to talk about Pioneer 11. So Pioneer 11 was a twin of Pioneer 10. They were identical ships. Now, Pioneer 10 launched in March of 1972. And in the 60s and 70s, when NASA would send planetary probes out, they would often launch twin spacecraft. And that was in case if one of the craft failed, there would be a second one to complete the mission. And that was certainly in the case on the first NASA probe to Mars, Mariner 3, which failed, but Mariner 4 did not and took the first close-up images of Mars. And then the first craft to orbit Mars, Mariner 8, ended up in the Atlantic Ocean, but Mariner 9 became the first craft to orbit the planet Mars. And they would also launch these craft within weeks of one another. And that was the case with the twin Vikings that went to Mars and the twin Voyagers that went to Jupiter and Saturn and beyond. But in the case of the Pioneers, Pioneer 10 left over a year before Pioneer 11, because for 11, they had an ambitious plan for that second spacecraft. After its Jupiter encounter, they were going to try and send it to Saturn using a massive gravity assist from Jupiter. So Pioneer 11 was launched April 6, 1973 on an Atlas Centaur booster. So this is a drawing of the craft. So I think I've shown this drawing before when I was talking about Pioneer 10, because like I say, they were identical spacecraft. So they had a number of imagers. They had a magnetometer. They had devices for measuring meteoroid and asteroid impacts, charged particle instruments to measure in the environment in interplanetary space, etc. So 11 instruments altogether on the Pioneer. And as it would leave the solar system forever, like Pioneer 10, it carried a plaque, this plaque, showing its origin point, third planet from the sun. There were 9 at the time. This map of where our solar system is in relationship to a number of nearby pulsars, a representation of a hydrogen molecule, and then a representation of human beings with a line drawing of the spacecraft behind them to show just how big we are. And like Pioneer 10, certain folk protested that we were sending smut to the stars. So I just wonder, in the news recently, there's a lot of folks protesting Michelangelo's David. I wonder if they know this sort of smut is sailing the cosmic sea. Compared to the Voyagers, which would launch in 1977, the Pioneers were very small and simple. In order to be reliable, it was spin stabilized at 5 revolutions per minute. It did not have a scan platform. So when it would image something, it would take a series of exposures each time the imagers on the revolving craft lined up with its target. It also did not carry a recorder. It transmitted its data in real time. It did not store them on a recorder like future craft like Voyager and New Horizons and etc. would do for transmission later. So And it was powered by 4 radioisotope thermoelectric generators powered by plutonium. And it provided a combined 155 watts of power at launch. And it transmitted through a 2.7 meter diameter high gain antenna at a rate of 1,024 bits per second. Oof. Amazing. So this is a trajectory that it would fly. It would fly out to Jupiter, encounter Jupiter, and then use Jupiter's gravity to alter its course and send it slightly above the plane of the solar system and send it basically across the solar system to encounter Saturn in September of 1979. And then once encountering Saturn, its gravity would change its course slightly and send it out of our solar system forever, never to return. So in December 1974, Pioneer 11 arrived at Jupiter, and several images were taken of its planets and moons. This is a raw image, and then they would clean up the image. This is that same image after they cleaned it up. And using this gravity, it didn't pass directly over the pole, but it passed up slightly north of Jupiter to use its gravity to fling it on towards Saturn. There's the drawing of the trajectory again for its 5-year trip across the solar system. Now, like its sister ship, Pioneer 11 experienced much higher levels of radiation in Jupiter's space than was anticipated. And this did affect some of the instruments, and some of those were turned off during the long cruise to Saturn. The craft, both Pioneer 10 and 11, were damaged by the radiation in Jupiter space. They just had no idea the radiation belts around that planet were so intense. So Pioneer 11 detected Saturn's magnetic field as bow shock on the 31st of August in 1979, about 1.5 million kilometers out from the planet, and proving that Saturn also had a magnetic field and also had intense radiation belts. So the spacecraft passed by the planet on September the 1st at an encounter range of about 20,900 kilometers, and it was moving at a relative speed to the planet of 114,000 kilometers per hour at closest approach. During the encounter, the spacecraft took 440 images of the planetary system, with about 20 at a resolution of about 90 kilometers. It also imaged Saturn's giant moon Titan at a resolution of 112 miles or 180 kilometers, and basically showed Titan as a featureless orange fuzzy satellite. Data returned from Pioneer indicated that the average global temperature on Titan was minus 193 degrees Celsius. The probe headed out of the solar system, but continued to send data about the conditions around it until November 24th, 1995, when contact was lost. The spacecraft had expected to live about 7 years, so to make it more than 20 since launch was quite the thing. Its sister craft, Pioneer 10, continued to transmit until 2003, and it's even though Pioneer 11 was in space for a shorter time, it was felt that the double dose of radiation for both Jupiter and Saturn shortened the life of Pioneer 11. Among its many discoveries were a narrow ring outside the A ring, which they named the F ring, and a new satellite, 124 kilometers in diameter, or pardon me, 200 kilometers in diameter. spacecraft recorded the overall temperature of the planet at its cloud tops is minus 180 degrees Celsius. And photographs indicated its atmosphere had much less in the way of features than Jupiter, and that the planet was primarily made of hydrogen. Now, had the pioneers not blazed the trail for the voyagers that followed, I don't think the voyagers would have done the job they did, particularly Voyager 2, which visited all 4 of the gas giant planets. Because of the intense radiation that the pioneers experienced at Jupiter and Saturn, they hardened the electronics on these craft so that they would not be damaged passing through the magnetic fields of these planets. And certainly in the case of Voyager 2, which went on to visit Uranus in 86 and Neptune in 89. I'm sure if the electronics weren't hardened on those craft, those missions would have never happened. So Pioneer 10 and 11 are voyaging out of the solar system basically forever as our emissaries into the space, unless the Klingons destroy them like they did in Star Trek V. Now, I mentioned this in the planetarium portion, but I'll say this again because I got this poster yesterday, so I stuck it in. We do have International Astronomy Day at the TELUS World of Science on April 29th. Free admission. We have solar observing. We'll have a telescope clinic, and we'll have nighttime observing from 7 till midnight. So if you're in the area, come on down, say hi, have a look through our telescopes, and all are welcome. I always mention heavens.
Can I add to that, Jeff?
Oh, sure.
Sorry, I was just going to say, and if you're a member, feel free to bring your scope down and set it up in the field. We'll have hopefully quite a few members out there with their scopes as well.
Right. Okay. Mostly Heavens Above is a great source of information for anything astronomical, for satellite tracking, for looking for comets. If you want to find your chart for Ceres, the dwarf planet Ceres, it's on Heavens Above. Our next What's Up is going to be on Wednesday, May the 3rd. Our next meeting of the RASC Edmonton is on April the 17th. Now, normally we have these on the second Monday of the month, but the second Monday this month is Easter Monday, so we bumped it one more week till April the 17th, and it is a members' night. And with that, I will say thank you, and if there are any questions or comments, I will take them now. And I see there's something in the chat here. What do we got here? Wahaha. Okay. All right. Is that for William Shatner? Yeah. Okay. Any questions, comments? Yes, for Bill Shatner. Okay. All right. Thanks. Yes, he had that way of speaking even back in 1960. Another chat. What do we got here? Oh, thanks, Jane. All right. Anything else? No? Okay. All right. Well, thank you very much. This is being recorded. I will clean it up and post it on YouTube in a day or so. And if you are around for Astronomy Day, come on by. If you're around for our meeting on the 17th, come by. They are open to the public. And I guess with that, I'll say goodnight and go Oilers.
Thanks, Jeff. Good job.
Thank you. Thank you very much.
Thanks, Jeff.
Yeah, thanks, Ed. Okay. All right. Good night.